So this is the step where we place the pi tin on the foam. So that Electrophorus is the pi tin. All right, I'm gonna draw this again as a before and after. So before and after. All right, so before we placed it on, we had our pi tin, and it's up in the air and we're holding on to it. All right, there's our cup that we're holding onto it with. And then we have the foam. So what do we know about the charges of these materials? Well, we know that the foam is negative because it was just rubbed by the cloth. So it has gained those electrons. So 1, 2, 3, 4, 5, 6. And then it has now 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our charge for the foam is negative. And the tin, it was just kind of hanging out there, and all of our objects started out as neutral, so this is still neutral. And I'm going to give this 5 protons. 1, 2, 3, 4, 5. And then it has, because it's neutral, right, we know that the Q equals 0, so that means it has the same number of protons and electrons. 1, 2, 3, 4, 5. All right. Now, in the second part, the foam and the pi tin are touching. Okay. You would be tempted. I think the most common, error that students would make is thinking that this is contact charging, which makes sense because they're in contact with each other. But we have to think about what kinds of materials they are. This is an insulator, right? And this is a conductor. So this first question is here to kind of guide your thinking with that. Can electrons move from the foam into the pi tin? We have an insulator and we have a conductor. Actually, the electrons cannot move from the insulator into the conductor because this insulator, the foam, wants to hold on tight to those electrons. So the electrons are going to stay in this insulator. Remember, those electrons don't move around very easily. So we have still, the electrons are going to stay right in here. So we have this is 1, 2, 3, 4, 5, 6. And the electrons aren't able to move, so they're going to kind of, as much as they can, get a little closer to that pi tin, but they're kind of stuck where they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oop, just 9. Okay. So they are in there. So can electrons move? No. Electrons are stuck in the foam because it's an insulator. Can electrons move? Can electrons in the tin move around? If yes, show how they move around in the drawing and tell what the name for this process is. Okay, well, there's an if yes. It means yes, they can, right? This is a conductor, so those electrons are free to move around wherever they want. So we know that our protons are stuck in one spot, right? We have our 5 protons, 1, 2, 3, 4, 5. But these electrons in there, they are repelled by the electrons that are in the insulator. Remember, this is a really electronegative. All right, that's negative and this is neutral. Those electrons are going to try to get as far away as possible. 1, 2, 3, 4, 5. They're going to push all the way up to the top of the pi tin. And If we have positive down on the bottom and then negative up on the top, what's that? This is polarization. So the process here is polarization. And basically, the electrons move to the top of the tin. So, what's the charge on the tin? Well, we still have 5 protons and 5 electrons, so it's actually still neutral, but it's polarized. And it's worth writing that twice. So the tin is neutral, but polarized. And the foam is negative.